Good morning, everyone. Dear students, we have all tried to give you a mode of the description of the some apparatus, some experiments which you are taking in your class 11, and all of you must be knowing how to write the practicals in your records. But before we begin with experiment 1, I would like all of you to know that you must first put in your record, you must put a diagram in the blank space, or a ray diagram if it's an optical experiment, or a figure which is or a lamina, or a small diagram which is necessary for your experiment. Then the date and the experiment number has to be put on the table on the copy. You begin with the aim of the experiment. Next, you have your apparatus required. Then you have your theory. In the theory, we should always first mention the working formula. And as we all will be doing experiments, you will gradually know the steps. So theory will first include the working formula. And then we go over to the procedure. Next to the observations. And then the calculations, results, and then you have your precautions. Okay. So I begin with all this. Even if you have not written it down, you will know gradually through the experiments. The experiment number 1 is to determine the length of the given hollow cylinder using a vernier caliper. There are several questions on this in CBSE and CHSE, but you can have a cylinder area, you can have a hollow cylinder volume, you can also have a solid cylinder, or you can have a volume of a beaker using a slide caliper. So, here, in the theory, we are going to now determine the least count. So, we will, in this vernier caliper experiment, we have to write the determination part both in observation as well as in theory. Because theory has the definition of least count, and you have to show how you standardize the main scale, how you standardize the vernier scale. So, it's all that we have to show. So, here I have standardization of main scale. So, between 0 and 1, that means 1 centimeter has 10 divisions. So, 1 main scale division is how much? 1 by 10. That is 1 by 10 means that is of 1 by 10th of a cm, which is 0.1 cm. So, the least count of the main scale is 0.1 cm. Next is number 2, standardization of vernier scale. This part will be recorded in theory as well as in observation before you start the table. So, in the standardization of vernier scale, you have how many vernier divisions here? 10 vernier. Coincides with how many main scale? You see here, you found the number of main scales here. Then it is 10 vernier divisions. This is 10 vernier division. These are main scale division. Large, small, all count. Don't count only small. Including small and large, count the total number. So 10 vernier coincides with 9 main scale divisions. So 1 vernier, simple maths. This is 9 by 10 main scale division. And what is 1 main scale standardized to be? 0.1 cm. So 9 by 10 of 0.1 will give you 0.09. I have already discussed this. So it will be, so 1 vernier division reads 0.09, 1 main scale division reads 0.1. So the difference gives you the 0.01 is the least count. Next, before that, you must talk about the zero error. So zero error, the zero error, I just told you that when the zero of the vernier, if it coincides with the zero of the main scale, when two lower jaws are in contact, then this instrument is supposed to have no zero error. Now, when the zero of the vernier scale is lying to the right of the zero of the main scale, when the two lower jaws are in contact, then you will have a positive zero. In this case, here the zero, when the two jaws are in contact, it is lying to the 10 is lying to the right, and Poincare coincidence is 1. So, zero error will be plus 1 into 0.01. So, it will be plus 0.01 in this apparatus, plus 0.01. So, this is part is this. The negative zero error is when the two jaws are in kept contact, the vernier zero, the lower scale, the vernier zero lies to the left. Here in this diagram, it is lying to the left. So here, this will be, if it is lying to the left, you see the vernier coincidence. Suppose 9th vernier coincidence is there, then 10 minus 9 into 0.01, that will be minus 0.01, which will be algebraically subtracted from the total reading to give the correct reading. So now in the theory, we wrote the working formula of the total reading. We defined least count. Then we found out, standardized the main scale, we standardized the vernier scale, calculated the least count. That part all should be entered again in your observation because you have observed it also. Then zero error, you have mentioned about the definitions, but what is the zero error in your instrument? Each one has to record differently. Somebody might be having nil, someone might be having minus 0.01, somebody is having, in this case it is plus 0.01. It has to be subtracted from algebraically. So let's go to the procedure. So here, so what is the procedure? First, the procedure, the main scale of the given vernier caliper is standardized. Then the vernier scale of the caliper is standardized. Least count of the caliper is determined. Zero error of the caliper is determined. The next, then the cylinder was placed in between the two lower jaws. The cylinder was placed between the two lower jaws, and here in my case, the zero of the vernier is lying between, it is 2.5 and 2.6. The vernier zero lies between 2.5 and 2.6. It is not coinciding with 2.5, neither it is coinciding on 2.6. So, the main scale reading is the reading of the main scale lying to the left of the zero of the vernier. So, zero के left में क्या है? 2.5. So, 2.5 will be my main scale. Since 2.5 I have recorded, so main scale reading portion I will record, least count column I will record 0.01, zero error I will record in the beginning, and then main scale reading I will write 2.5. Because the reading of the main scale lying to the left of the zero of the vernier is recorded as the main scale reading in centimeter. This is in centimeter. 2.5 cm. Unit has to be mentioned in the column. Then out of this 10 divisions, since 0 is not coinciding in line between 2.5 and 2.6, you see which one is coinciding? So out of this, 1, 2, 3, 4, the sixth one is coinciding. If the vernier sixth is coinciding in total coincidence, like here you had no zero, no, like this is the sixth vernier division, coinciding totally with a main scale division. It might be a small one or a larger division. So it is coinciding totally, there is no packets. Then vernier coincidence is 6. Main scale reading is 2.5, column vernier coincidence is 6. So what will be my vernier scale reading? Vernier coincidence multiplied by the least count. That will be vernier scale reading. So that will be VSR will be 6 into 0.01, which is 0.06. Then total reading will be 2.5 plus 0.06, which will be 2.56 will be my total reading, uncorrected length of the cylinder. And then I have to subtract minus of plus 0.01. So 2.56 minus of plus 0.01 will be 2.55 will be my correct length of the cylinder. So let's see. So here let me read it out. So first the cylinder was placed between lengthwise, this was lengthwise, between the two lower jaws, and the reading of the main scale to the left of the vernier is noted. If the vernier zero lies to the division between the two divisions of the main scale, this gives the main scale reading. The left of the zero. Next vernier coincidence which is noted, that is my sixth division, multiplying VC into LC least count determines your vernier scale reading. Then MSR and VSR are added to determine the total reading in centimeter. Zero error is subtracted algebraically from total reading to determine correct reading or the correct length in centimeter. This procedure is repeated 10 times. This procedure is repeated 10 times and the correct length of the hollow cylinder was noted. So next we go to the observation part. In the observation part, I have written star marks, means you repeat whatever, how you determine least count, what is your value of the zero error, how determine, all that you enter again. So least count is 0.01 centimeter, we have already determined, zero error we have determined, in my case it is plus 0.01. Then the determination of length, you will put in the serial, you have to take 10 readings, least count you will put as 0.01, then MSR will be 2.5, then vernier coincidence will be 6, then vernier scale reading will be 0.06, MSR plus VSR is 2.56, then your zero error which will be minus 0.01, that is minus of plus 0.01, which will give you 2.55. Similarly, you go on recording this length. It will be 2.5, 2.5 somewhere. Can your height change? No. If it was a vernier coincidence 9, please understand this part in the vernier. If it was 2.5 and VC was 9, it can become 2.6. 2.60, 2.59, these are close lengths. But since it is 6, the vernier divisions may go 1 or 2 divisions here and there. So the vernier coefficient will be 5, 6, or even 2 can go over to 7. So 2.56, 2.55, 2.57, something like that, you will get the total reading undirected. And then you subtract algebraically the zero error, you get the total correct reading and take the mean of it. Then the mean will be determined the calculation part. After observation, you have calculations. So what is your result? After finding out the mean of those 2 point something, it will be 2.55 something or 2.561 something like that. Then precautions will be, you have the result, you will write the length of the given hollow cylinder. I have just put a value there. Here it is something 2 point. There when I determined it was 3.21. The number of observations, you have to write down what are the precautions that you have taken. You have to have a fairly large number of observations. Least count and zero error should be noted carefully, and the parallax should be avoided. What do you mean by parallax? That means when you see the vernier coincidence, whether the sixth is in line or whether the fifth is in line, you have to say carefully, seeing, putting small chalk marks, and then rubbing it and see directly what is, if there is no parallax. Then simultaneously you will see the two images coinciding. There is no, along with the motion eye of the observer, these two image points are moving together, so there is no parallax. Now, there are this experiment one finishes, but there are various other readings, other questions that come in your exams. Suppose it is given A as the volume of a hollow cylinder. You will have to calculate. This has to be a total bracket here. It will be total d square minus d square is to be subtracted first. Here is one part is missing out here. So pi by 4 into d square minus d square into L in centimeter cube, where d is the external diameter and small d is the internal diameter, L length is in centimeter. So this is about your volume. So how many tables you have? Table 1 for external diameter, that will be determined by a pair of lower jaws. So here, this is the lower jaws, this is table 1 is determined length, we have determined already length. Then you can have your external diameter, where is this one? Length you have determined. This is your hollow cylinder, length table 1. Table 2, you will have 10 observations for table 2, capital D. And table 3, you put the upper jaw, you put it inside, close the jaws, put it inside, and then stretch. And find out the lower one where 0 is lying between 0.8 and 0.9. So left of 0, 0.8 MSR. Then you take the main scale, and then the vernier coincidence, vernier scale reading, total, as you have done it for the length, you do the same thing for your internal diameter small d. So we have calculated table 1 for small L, table 2 for capital D, table 3 for small d. And calculation part gives you the volume pi by 4 into d square minus d square, that is d plus d into d minus d by 4 into L in cm cube. Please don't forget to write the unit. Okay? Then comes to determine the volume of a beaker. Suppose this beaker is given. Aim is beaker and slide caliper. How do you do it? You have to use the stem of this. You have to use the stem of this. Here, you have to see this, yes, you have to find out the stem like this, the height of the beaker with the help of the stem. Now here you will see the 0 is lying between 7.3 and 7.4. So what will be the main scale? 7.3. Then find out the vernier scale division here. And then vernier coincidence into least count gives you the vernier scale reading. Add MSR and VSR gives you the total reading for the depth. And if you continue like this, all the total readings you have got, you have the 0 error plus 0.01 which has to be subtracted and get the correct height of the beaker. You know table 1 is for the height. And what is the table 2? The internal diameter. Here you can find out. So you can say that you have to find out this way this part of this internal diameter. Again you can find out this. So for the volume of a beaker, and then the height, and pi d square by 4 into L. Is that clear? So you will have different formulas for each. Suppose I am giving you a solid cylinder. This is better. If you have a solid cylinder, calculate the volume of a solid cylinder using a slide caliper. So what will be the apparatus required? Solid cylinder and slide caliper. What are the three tables that you again least count, vernier, 0 error, all that has to be mentioned in your theory. Procedure is the same for each observations. Now here, this for each parameter you have to determine 10 times. Number of observations should be fairly large. So external diameter is one table and length will be another table. So it will be pi d square by 4 into L cm cube will be the volume. So in the theory, the first part that you will write in the working formula for a solid cylinder is V for solid is pi d square by 4 into L cm cube. Then capital D is determined as external diameter using the lower joules. And length is also determined using the lower joules. So you will have 20 observations, 10 for L and 10 for M. So this finishes the different varieties of questions that you get in your practical for the experiment 1. Next comes the screw ball.